Okay, number four says, in the sieve of Eratosthenes, for numbers less than 100, explain why after crossing out all the multiples of 2, 3, 5, and 7, the remaining numbers are prime. Okay, so let's look up the sieve of Eratosthenes. The good thing is I can misspell it and the computer's still gonna find the thing. Let's look at an interactive one. So I encourage you to do this with your students. Okay. So let's see. So the way the sieve works, and I'm not sure how it's gonna work on this website, but let's try it. So I'm gonna choose two, and it's gonna get rid of all. It's a way to find primes, okay? To find all the primes less than 100. Well, two is a prime, but all the other multiples of two are not prime because they're a multiple of two. So 2 times 3, 2 times 4, 2 times 5, and so on. So I just got the only one I can keep is the 2. But all the other multiples of 2 I have to get rid of. So now let's look at 3. I get to keep 3, but all the multiples of 3 are not prime because they're multiples of 3. So they have some other factor. 5 is prime, but all the multiples of 5 are composite, so we don't use them. So far we have 2, 3, and 5, and we're left with 7. Now, I guess there's a couple of ways to answer this question because it said why after 7, I only get numbers that have already been shaded out. So the rest of the numbers are primes. I could do this for all of them. I'm not gonna get any new numbers. So everything that's left is a prime. Okay. And I would say, so why did I just have to go up to 7? Because there's a couple of ways to answer this question, I guess. Um, why is it that I went up to 7 and then everything that's left is a prime number? That's the question. So I would say so here's one way to say it. So I think one way to explain it is this way. If you take any of the numbers that are left, say 11, if in order for it to be a composite number, I would have to find a number a number less than the square root of 11 that would divide it. The square root of 11 is, what's the square root of 11? The square root of 11.
3.32.
3.32, and it probably repeats. So I would have to find a prime number less than 3.32. But the only, well, it would be these two, right? But I've already used that number. I've already used the 2 and the 3, and I've already crossed out all the multiples. And I didn't cross out 11 when I've crossed out multiples of 2 and 3. Okay? So that's kind of how it's going to go with all of these. If I take the square root of 13, what do I get? What do I get? The square root of 13. So again, 3.61, the numbers that are less than 3.61 are 2 and 3, but I already used it. I already used those to and crossed out a bunch of numbers, and I didn't cross out 13. Oops. I accidentally unchecked 12, but we'll ignore that. So then the next one is 13. What's the square root of 13? Oh, did we just do that one? Yeah, we just did that one. Never mind. The next one is the square root of 17. But I already used 2 and 3 and didn't cross out 17. So it's the same answer. Let's go all the way to 37. What's the square root of 37? Well, that would be 6.08. So I would have to find prime numbers less than 6.08. That would leave me with 2, but I already used 2 and I didn't cross out 37. 3 and 5. I crossed out all the multiples of 5. All the multiples of 5 are over here and over here. So let's go all the way. Let's do the last two. Let's do 89. The square root of 89 is 9.43. So I have to find numbers that are prime numbers that are less than 9.43. So that's these three. There's nothing. I've already crossed out all the multiples of 7 and did not cross out 89. And the last one, I'm doing it on the right side. The square root of 97 is 9.85. So it's the same answer. I've already used 2, 3, 5, and 7, and I never crossed out 97. because all the multiples of 7 are, yeah, they're harder to find. 7, 14, 21. I don't think there's a real clear pattern. Well, maybe 21 and then 28. No, 28, 35. They do kind of go in a pattern, but I never crossed out 97. So the biggest prime number in the whole set is 97, and its only possible factors are 2, 3, 5, and 7, but they're not. So use my explanation to provide your best.